This time we're talking about synthetic division, which is a process for dividing a polynomial by a binomial. For our purposes, we're only going to divide a polynomial by x plus or minus a number. And this time we're looking just at the mechanics of it, not about what we're going to be using it for. We'll talk about that a little bit later. So just pay attention to the process, practice it, get good at it, and then we'll discuss what it's used for. First thing we want to look at is our polynomial here. And we're going to write down a little grid. I'm going to put a little bracket there. And then we're going to write in order the coefficients of each of the terms. So 2x fourth, 7x cubed. There's a missing x squared term, so we have to account for that because where the numbers are in place here tells us essentially the degree of that monomial. So we have to make sure we keep a space for x squared. Just like 11 and 101 are different numbers, right? The 0 there means something. We need to include it in our synthetic division too. So then we are at our x term, the 1, and negative 12 for our constant term. Leave space for a row of numbers there and draw another line. Whatever number this is, change its sign and put it in the little bracket over there. So plus 3, we put a minus 3 in here. Now the process is repetitive, and if the numbers are nice, it's a fairly easy process. You'll run into something in MyMathLab with some god-awful hideous numbers, in the millions even. So start with this number. Bring it down here. Just bring it straight down, don't do anything to it. And then each number down here, we're going to multiply by this number. So negative 3 times 2 gives us negative 6. Okay, so we're multiplying times, that looks terrible, gives us negative 6. And then we're adding. 7 plus negative 6 is 7 minus 6, that's 1. Negative 3 times 1 is negative 3. 0 plus negative 3 is 0 minus 3, or negative 3. Negative 3 times negative 3 is positive 9. 1 plus 9 is 10. Negative 3 times 10 is negative 30. Negative 12 plus negative 30 is negative 42. Okay, that's the end of the process. We need to discuss what this means here. This means is when we divide this polynomial by x plus 3, the quotient, Q for quotient, is 2x to the third plus 1x squared minus 3x plus 10 with a remainder of 42. Negative 42, excuse me. Okay, when we divide a polynomial by a polynomial, we get another polynomial, but it doesn't divide it evenly because we have a remainder. So how to think about this is if we started with a 4th degree here, then our quotient's going to be a 3rd degree. It's always going to be 1 less than the polynomial we started with. And this last number here is always going to be the remainder. So you can think of it this way also. This is the remainder. This is our constant term, then our x term, then our x squared term, then our x cubed term. Or just remember that the degree of this is 1 less than the degree of that. Want to see that again? Rewind. It's the beauty of video. Let's try another one. Got it written here for ease. We've got x cubed minus 2x squared minus 8, and we're dividing by x plus 2. So our setup, bracket, line. We know what goes in the bracket. It's going to be the opposite of this, so negative 2. And then we've got an x cubed term of 1 minus 2 we're missing an x term, right? We go straight from our x squared to our constant. We need to put that placeholder 0 in, and then our -8 here. Bring the first one down. So bring the 1 down, then multiply. -2 times 1 is -2. -2 plus -2, -4. -2 times -4, +8. Add those, we get 8. -2 times +8 is -16. And that gives us -24. Okay, it's just repetition. Just add, multiply, and then add. This is our remainder. And our quotient here, and at this point, that's all we're asking for is the quotient and the remainder. This was x cubed, so this will be x squared. 1x squared minus 4x plus 8 with a remainder of 24, -24. Okay, that's the process. We're going to practice it a little more as we look at some of the applications of it, but we'll do that next couple times. Have fun.